Hey guys, so welcome to my video. Today we are going to discuss sorting algorithms. So let's get into it. First, what is sorting algorithm? So basically, sorting is arranging things in a certain order. You can, let's say, you're arranging things from the smallest to biggest, tallest to shortest, from dark to light, good. And anything you can arrange things in a certain order. Alright, so let's have an example. So we have my set of Uno cards right here. So let's say we want to arrange the cards from the lowest number to the biggest number, or smallest number to the biggest number, or largest number. So what we will do, let's say put 1 right here, then 2, then 3, then 4, then 5. We arrange all the numbers, right, just like that. So what we did here is that we sorted the cards from the smallest number to the largest number, so from 1 to 9 in a certain order, right? So now we know what sorting is. Let's move on to algorithm. So algorithm is a set of instructions to do something. So sorting algorithms is to arrange things in a certain order by a set of instructions. So there is a set of instructions to arrange things in a certain order. So how you arrange things in order. So that's what sorting algorithms is. So there are many kinds of sorting algorithms. There are the bubble sort, the selection sort, insertion sort, merge sort, heap sort, quick sort, and there are other special kinds of sorting algorithms like the bucket sort, counting sort, and Radix sort, and many other stuff. So we're gonna discuss them one by one. So let's go. Alright, so in bubble sort, what we do here is that we compare two numbers, right? Then we compare, if the number on the left is greater than the number on the right, then we switch them. We swap the numbers, right? So we swap 9 and 2 here. And from this, compare the next two numbers. So again, if the number on the left is greater than the number on the right, we swap. So we swap. So 9 is greater than 5, so we swap. Alright, then we have 3, 9 and 3, so it's still the same, so we swap. We have 9 and 1, so we swap. And 9 and 8, so we swap. And 9 and 4. So 9 is greater than 9 is greater than 4. So we swap the cards, or the numbers. After that, after you swap, you do one cycle. You just repeat the same process. Compare this. If this is bigger, then switch, but 2 is less than 5, so it just stays there. Then you move on to the next, then you switch, and so on and so forth until you sort the numbers. So to continue, 5 and 1, you switch. 5 and 8, no. 8 and 4, yes, you switch. 8 and 9, so no. Then repeat again. 2 and 3, no. 3 and 1, yes. 3 and 5, no. 5 and 4, yes. Then 5 and 8, then 8 and 9, no. Again, repeat. 2 and 1, yes, you switch them. 2 and 3, no. 3 and 4, no. 4 and 5, no. No, no. Alright, so it seems it is all sorted. Then, ta-da! That's how you do it. That's the bubble sort. So our next sorting algorithm is selection sort. So what we do in selection sort is we just set the first number as our minimum number. Then we compare our minimum number to the next number. And if the next number is less than our minimum number, then that next number becomes the new minimum number. So but here in our cards right here, 4 is greater than 2, so 2 here is still the minimum number. Then we compare it to the next number, which is 8, so 8 is still greater than 2, so 2 is still the minimum number. Then 1, yeah, so 1 is less than 2, sorry, 1 is less than 2, so 1 here is now our new minimum number. Then we compare to the next, yeah, so it's still 1 because 3 is greater than 1, compared to 5, so it's still 1 because 5 is greater than 1, then 9, yeah, so it's still 1. And after we compare to all the numbers, we switch our minimum number with our first number right there. Yeah. And 1 right here is now part of our sorted part of the numbers. So next we get the next number 4 as our new minimum number. So then we compare it to 8, so it's still 4 because 8 is greater than 4. Then 2, right, so 2 is less than 4, so 2 is now our new minimum number. Then we compare to 3, then 5, then 9, so it's still 2. Again, we swap our minimum number with the first number, right? Then do the next. Again, 8, new minimum, compared to 4, so 4 is now the new. Then 3, yeah, so still it's gonna be 3. Then compared to 5, then 9, so it's still 3. So 8 and 3 will switch. Yeah, right there. So we have 4 as our new minimum. We compare it to all, it's still 4, so 4 stays right there. Then next is 8. Yeah, compare, so it's 5 and 9, so we switch. And compare to the next. Now, no. So there. Sorted. Selection sort. Our next sorting algorithm is insertion sort. So basically in insertion sort, you have a marker. So on the left side of the marker is our sorted elements or numbers, while on the right side is unsorted. So we assign sorted right here, then we assign our key in our unsorted elements. So let's say 4, then you compare 4 to the numbers on the right side of the marker, then you swap, right? You swap if it is less, then the marker moves. Then 1 here is our new key for unsorted. Then you compare it on the left side. So yes, we compare, so we swap, and 5 here moves. Yeah, we just insert it right here. So it inserts, no? The values insert. Then we move the marker. Yeah, then our new key becomes 8 here. Then we compare. Yeah, so we just insert it right there. Yeah, so the marker moves. Then our new key is 3. Then we compare to the left side. Compare to 8, compare to 5, compare to 4, compare to 1. Well, but since 3 is less than 4, and 3 is greater than 1, so we insert 3 right here. So the cards right here will just move. Alright, then our marker right here will move. Then again, this is our new key. And compare. So we just So what happens is just inserts right here in its proper place. So all the elements move. Yeah, then the marker moves. So we are left with 9. So of course 9 inserts right here. Yeah, so the marker moves. Then there you have it. It is now sorted. So that's how insertion sort works. So basically in insertion sort, you just start with a key or sorting number in the unsorted side of your numbers, then you compare it to the sorted side of your number. So if it's greater or less than, so if it is less than the number in your sorted numbers, then you just insert it right there because it is already sorted. So if it is less than a number, then you just insert it right here because it is understood that the next number is much less than your key. So you just repeat it until the marker reaches at the end of your numbers or your list. And there you go, you have your sorted. You have no unsorted numbers left, none. So everything is now sorted. So ta-da!
So our next sorting algorithm is Heap Sort. Right, so basically in Heap Sort, you just first you convert or change your list of numbers into a tree. So I assume you already know what a tree is because you're looking at Heap Sort. Okay, so you convert this into a tree. So it goes like this. There, right there, right there, and right there, and there. So that is now a tree. So the next step, you rearrange the tree wherein the parent node, the value of the parent node must be greater than its children node. So our greatest value here is 9. This becomes a parent node. So 8 and 5 is its children nodes. So yeah, 9 is greater than its children node, so it's good. So put it right here. Right, 8 is now a parent node. 3 and 2 is less than 8. Right. All right. The next we swap our lowest value, 1 right here, to our largest value, which is 9. So we swap 9 and 1. Right. And after that, our swapped large number right here goes into our new list of numbers. Let's put it right there. This is the last number in the list. Right there. And next, after that, you rearrange again your tree, where children node again is bigger than the children node. I mean, the parent node is bigger than the children node. So it goes right this. It goes like this. Then you swap again 1 because it's the smallest number with the largest number, 8. Yeah. Then 8 goes into our new list of numbers. It goes beside 9. Then again, you rearrange the tree. Yes, it goes like this. So again, switch. Yeah, 5 goes right here. Yeah, so it's out. You take it out of the tree, then put it in another list. Yeah, the list. So again, rearrange. Goes like this. Then again, you swap. Then 3 goes right here. Here. Then again, rearrange again the tree. So we're left with this one. You swap. 2 goes right here. And 1 is left, so it goes right here. So there you have it. It's all sorted, and that's Heap Sort.
So next, we have shell sort. So this kind of sorting algorithm is kind of more complicated than our previous sorting algorithms. So basically in shell sort, you don't compare
numbers that are adjacent or beside it, but instead you compare numbers that are much more further than one number. Let's say you have a gap. All right, so basically just get the gap between the numbers, then you compare it. So it's the same, compare it to the left side. If it is bigger than your, let's say, chosen number, then you swap, then the gap reduces, the gap gets smaller until everything is sorted. So that's just how it works. So in our example right here, to find the gap, we just count first the numbers that we have, 1, 2, 3, 4, 5, 6, 7. Then we divide it into half. So 7 divided by 2 is 3 because there's a remainder 1. So yeah, you just have 3. So our gap is 3, right? So let's say we start with 1 right here. So the gap is 3, right? So we compare 1 to a gap 3 cards from it. 1, 2, 3, right? So we compare them both. Yeah, 5 is greater than 1, so we swap them both. Right. Right, since we cannot move on further, we move on to the next number to the right. You're right here, right? So we move on to the next number. So 4 is now our new chosen number. So we still have the same gap, 3. So 1, 2, 3 is 4. 3 is not greater than 4, so we move on to the next. Here, 2. So our gap is 3. 1, 2, 3. Yeah, so 8 is greater than 2, so we swap them both. Alright. Then we move on to the next number. So we have 9. Then we compare it with the gap of 3. 1, 2, 3. Yeah, compared to 5. So 5 is less than 9, so we just leave it there. Then we compare 5 and 1 because it has a gap of 3 also. So 5 and 1. Yeah, 1 is less than 5, so we do not switch. So after that, we move on to the next cycle, and the gap is reduced to 1. So basically what happens is that 3, the gap is 3, right? Then we divide the gap by 2. So 3 divided by 2 is 1 because, yeah, there's a remainder. So we can only have 1, 2, and 3. So our gap now is 1. So we start with the number at index 1. So index is the numbers right here. So this is index 0, this is index 1, this is index 2, index 3, index 4, index 5, and 6. So index 0 right here, and this index 1. So since our gap is 1, so we start at index 1. So this is 3 right here. So we start at 3. We compare our numbers. We compare our number with a gap of 1 to the left. So 1 is less than 3, so it's not. So you move on to the next number. Compare 2 to 3. Yeah, 3 is greater than 2, so we switch. Is 1 greater than 2? No, so we leave it there. So after that, we move on to the next number. Compare 3 and 5. 5 and 3, no. 3 and 2, no. 2 and 1, no. Move on to the next. 4 and 5, yes, it's greater than 4, so we switch. 3 and 4 and 3, 3 and 2, 2 and 1, no. Move on to the next number. 8. Compare it to numbers on the left. Since our gap is 1 already, there's no number greater than 8, so move on to the next. We have 9. Compare it to all the numbers on the left, so it's still less than 9. So, ta-da! It ends here. So that's shell sort. So next, we have our quick sort. So basically, in quick sort, we choose a pivot element. Let's say 4 right here. It's best if you choose in the middle. Then you swap your pivot element to the last element or number
in your list right here. And you swap 3 and 4. And then starting from the left side, you get a number that is greater than your pivot element, which is 4. So we get a number that is greater than 4. And starting from the right, we get a number that is less than our pivot number. Then after that, if we are able to get one greater number than our pivot and one lesser number than our pivot, these two numbers we swap. Right, so let's say 4 is our pivot right here. Starting from the left, we get a great number greater than 4. Yeah, so that's 5. And starting from the right, we get a number less than 4. So 9 isn't, and it is 1. So 1 and 5 right here will switch. Alright. Right. And then get the next. So we do that again. Starting from the left, we get the greater number than 4. So that's 8. And less than 4. So that's 3. And we swap. Alright. So again, get number greater than 4, which is 8. And number less than 4, which is 2. So right here, you can notice that the lines have crossed, right? So the lowest number is right here already, and the greater number is right here. So that means you have to stop. You stop right there. So after we stop, we swap our pivot number with the largest number that we got from the left, which was 8. Yeah, right there. And since we have already sorted numbers, some sorted numbers in this part, let's say we just divide it into 2 parts. Yeah, right here. So again, we choose a pivot number. Let's say 9. So 9 will switch with this, with the last number. Right, then starting from the left, you pick the number greater than 9. None. Yeah, since there is no number greater than 9, so it's just that. Alright. And on the other part, choose a pivot. Let's say 3. And you swap with the last number. Alright. And since it doesn't have any number greater than our pivot, so it stays just like that. So when we bring them back together, alright, they're all sorted. And that's how quicksort works. You just pick a pivot number, then put it in the last element, choose a number from the left that is greater than our pivot number. On the right side, we choose a number less than our pivot number, then we swap continuously until our lesser number crosses with the greatest number from the left. So when that happens, we stop, we swap our pivot number with the greatest number that we got, and just repeat the process. So you can split the numbers into 2 groups, so it would be more easier to sort. And ta-da! It's done. So our next sorting algorithm is merge sort. So basically in merge sort, you just split the numbers into half. You continuously split them into half until they're all individual numbers. Then you merge them back again by sorting it in every step. Alright? So let's go in our example. Let's say we have this set of numbers. So we divide them into half. Becomes that. Right? Again, we divide it into another half. Yeah, right there. Yeah, and this separates right that. So we have our 1, 2, 3, 4. We have 4 sets, right? Then we divide it into another half. So it becomes right here. Separate, separate,
separate and separate. Alright, so they're all individual numbers already. What you will do next is you sort them again. In the same manner you divided them. So we sort 3 and 8, we merge them. Yeah. So you compare the same time if the left side is greater than the right side. So here, 4 is greater than 1. So when you merge them, it becomes this one. So 5 and 2, yeah, compare them. So 2 is less than 5, so it switches, but it merges also. So 9 is also, yeah, just alone. Sad. It stays right there. And then, on the next step, merge these two numbers. So we sort them the moment we merge them. So when we merge them right there, so it's gonna be sorted. Yeah, divide by compare to number on the left. Yeah. Right here, when it merges, yeah, it's already sorted. So it's back to two sets of numbers. And when you merge them, yeah, you sort them. So it becomes right here, gets moved. Yeah, there. Yeah. Alright. So that's what happens when you do merge sort. You merge them. You break them down, you merge them again. Yeah. Alright. It's done. That's merge sort. You merge them while comparing them at the same time. Right? So basically just divide them into half until they're all individual numbers, then you merge them back together while comparing it or while sorting it. Alright, you have them. That's merge sort. So in our sorting algorithms, we also have special sorting algorithms. So to name a few, these are the bucket sort, Radix sort, and the counting sort. So these are special sorting algorithms because of their time complexities and stuff. So today we're going to discuss all three of them, starting with the bucket sort. Alright, so we start with bucket sort. So basically, in bucket sort, we just create 10 buckets because we're going to use buckets to sort all the numbers that you have here. We have a list of numbers. So first, we create 10 buckets right here, and we label them as bucket number 0, bucket 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we assign each number or decimal to bucket by multiplying 10 because you have 10 buckets and the number that you have. So what happens? First, we have 0.7. So bucket sort usually is used with decimals. So again, you multiply 0.7 times 10 because you have 10 buckets. It's usually always 10. So you can, so it would be easier to place them in the buckets. So multiply them by 10. So that's 7, right? So you put them in bucket number 7. Alright. And then we do this to our second number, 0.1 times 10. So this becomes 1. So we put it right here. And 0.31, that goes to bucket number 3. 0.42 goes to bucket number 4. 0.47 also goes to bucket number 4. And 0.39 goes to, yes, bucket number 3. So, and after that, you sort the numbers that you have. You sort the numbers in each bucket. So, yeah, 0.1 is 0.1 because it's alone. 0.31, 0.39. Yes, it's already sorted. 0.31 is smaller than 0.39. 42. Oh, so it's same. So it's already sorted. So if it's not sorted, you sort this using insertion sort, right? We already discussed this, so I think you already know how to do insertion sort. So you do insertion sort in the buckets, and when you come up, when you already sort everything that's on the buckets, you make another list. So our new list would be, so you count the list, you fill in the list from top to bottom. So that would be, our new list would be 0.1, then 0.31, then 0.39, then 0.42, 0.47, and then 0.7. Alright, so let's just square this. So right, it's all sorted, right? 0.1, 0.31, 0.39, 42, 47, and 0.7. So that's how you do it. That's bucket sort. So next we have Radix Sort. So basically in Radix Sort, we sort the numbers. So we sort them using its significant figures like the ones, tens, place, hundreds, etc., and so on. So in our example list of numbers right here, we will sort them by ones, tens, hundreds, thousands, etc. So first, we sort them using the ones place. So it's right here, the underlined numbers. These are the numbers in ones place. So it's 0, 5, 5, 0, 2, 4, 2. And then next, this is the sorted ones place numbers. So as you can see, 170 is written first, the 90, because even though it has 0, it both has 0 as their ones place. 170 is written first, so we put 170 first, then 90. Alright? So next, after that, we sort using the tens place. So right here, the underlined numbers. These are the tens place significant figures. 7, 9, 0. This is 1. Because, yeah, anything, it is already assumed as 1 if it is not there. Right? It's not 0. So ones, yeah, 2, 4, 7. So and this is the next sorted tens place significant figures. So 802, yeah, that's 2 right here because 0, then 1, then 2, then 4, then 7, then 7, then 9. Now we move on to the hundreds place. Yeah, right here, the 8 in 802. Yeah, the 1 in 2. Yeah, it's missing, so it's counted as 1. Then we have 1, 0, 1, and 1. So what happens next is, ta-da! Oh, sorry. This is what happens next. 2, 4, 70, 45, 75, 90, 170, 802. So 2 comes first because, yeah, it's the least number, right? It doesn't have any tens in it or hundreds, so it comes first. Right. Then 24, yeah, because it doesn't have any hundreds, and yet 2 is greater than 4. It's less than 4, sorry, so it comes first. The next, and so on. Yeah, 90 and 70 and 75 and 802 because 8 is the biggest. So that's it. That's Radix Sort. So lastly, we have counting sort. So basically in counting sort, you just count how many times the number appears in the list. And then you do some addition and subtraction. And then you place them in their proper places. So in our example list of numbers right here, the next step you're going to do is you're going to make another list of numbers from, 10 list of numbers. So initially, we have 0 right here. All of these numbers are 0. So what you're going to do is you count the number of appearance of the numbers, right? So 1 is going right here. 1 appears once, then 4. It only appears once. Then 1 again. So this becomes 2. Then you have number 2 here. Except number 2 appears first 1. Then you have 7. So it appears here. Here we have 1, 7. Then 5. Then we have 2 again. So our number 2 right here becomes 2. Alright? And then you add the two numbers, both of them, the current number and their previous number, right? So in here, it's 2 plus 0, so it's still 2. And for the next, you have 2 plus 2, it becomes 4. And for the next number, you have 0 plus 4, that's 4. Then for the next number, we have 1 plus 4, that's 5. And for 6, 1 plus 5, we can put 6 again, 0 plus 6. And for 7, we have, for the next number, you have 1 plus 6, it becomes 7. For the next number, it becomes 7 because 0 plus 7. And for the next, the same, 0 plus 7, that's 7. Alright? So next, you place them in their proper places, right here. So we have a list of 7 numbers because initially we have 7 numbers, right? So we place them in their proper order, proper place. So 1 goes right here. So 1 right here, this one, the numbers right here, they minus 1. So this becomes 1. And then 4, 0, 1, 2, 3, 4. So it goes right here. And 4 right here becomes 4. Then we have 1. So 1 goes here. It's still 1. And our 1 here becomes 0. Right? Then we have 2. So that it goes here. Oh, sorry. It's 2. Right? Then our 2 right here becomes 3. Then we have 7. So it goes at 7. Then we have 5. Oh, so So our 7 right here becomes 6. Then 5. So we put 5 right here. And our 5 right here becomes, our 6 becomes 5. Then our 2, place it right here. Then our 2 again, 3 becomes 2. So that's it. It's already sorted, right? So that's how we do counting sort. Alright, so now we have seen all the different kinds of sorting algorithms. So I hope you learned everything you need to know about sorting algorithms. And so thank you for listening. Thank you.